Hello, today I am going to explain about the voltage multiplier. Okay, how does this voltage multiplier work and what type of conclusion we are going to get from this experiment. Okay, as the word voltage multiplier is familiar for multiplying the voltage. Suppose the voltage, suppose we have a voltage of 12 volt, then we can multiply it with the other term 2 or 3 or 4 or 5, and we can get the more voltage. 12 2s are 24, 12 3s are 36, 12 4s are 48. Okay, um, for this we need a AC source. For this, a sinusoidal wave symbol is given over here. 220 volt AC is given to the transformer, and the transformer is set in such a way that its output is around 6 volt. Okay, we call it as a BM. Its output, let us call it as a BM. Okay, we can take generally 6 volt in a lab, or we can take 12 volt according to our choice of this capacitor and all. Okay, now we'll design a circuit in such a way that we'll place a capacitor. It is a symbol of capacitor, and again we'll place a diode. Okay, negative terminal of diode and positive terminal. Okay, again negative terminal down, positive terminal up, and we have kept a capacitor in such a way. Okay, in our breadboard we can do this type of experimental setup. So after this, uh, we have a little bit thing to know. Okay, what does it happen actually? Okay, it is a AC source. Okay, it is a AC source. So let us assume that at first this terminal is positive terminal and this terminal is negative terminal. We know that the frequency of AC source is around 50 hertz. Frequency 50 hertz means in 1 second the AC source changes its polarity 50 times from up to down. Positive, negative, it gets changed for the 50 times. Okay, so if this is positive, this is negative, then it is connected with the positive one, and it is connected with the positive one, but in this two case it is connected to negative one. So this two diode will be reverse biased and this two diode will be forward biased. So then we can in this case, when this have a positive terminal and this have a negative terminal, we can assume that these two diode are joined with a wire. Okay, there is no any diode because it is forward biased, and here is a backend space in this two is place. So whenever we see in this one compartment, okay, then positive terminal is going from this diode to this term. So this one polarity is being positive over here and the other one is negative. So there the voltage induced is Bm. So at what voltage this capacitor gets charged? We'll use a Kirchhoff's voltage law in this field. Okay, so here is positive, negative, negative, positive. So here the voltage is Bm. So for this case, okay, case 1, for case 1 I would like to write here case 1. Okay, Bm minus, in this capacitor let us call as a Bc1 is equal to 0, because both negative negative are there, so we need to give a minus. Okay, then Bc1 will be equal to Bm. So whatever the voltage it is coming over here, same voltage will be dropped on this capacitor. So it is the thing we need to know. So I can write here as a Bm. Okay, it is also Bm. So in another case, what happens, this terminal will be positive charge and this terminal will be negative charge. So this is negative now. So what happens, positive is connected with positive, positive is connected with positive. That means these two will be forward biased, these two will be reverse biased. That means now if we see in this one compartment, we'll forget about this now. Okay, we'll don't talk about this now. So we'll, in this compartment, what we can see, this is negatively charged, it is positively charged. So positive charge is coming from here and it gets accumulated in this capacitor. Negative charge coming from here accumulates in this capacitor. So what happened is that now again we will apply a Kirchhoff's voltage law in this loop. Okay, in this loop, because it is closed circuit. Okay, it is a suppose I mean that it is open circuit and this one is a closed circuit because it is forward biased. Okay, so what happen, plus minus, let us call this the charge to be accumulated in this capacitor is bc2. Likewise we have supposed to have bc1 before. So what can we do is plus minus and minus plus minus plus, that means bc2. Okay, for the next case we can write here bc2 minus bm and again minus bm, because it is bm is equal to 0. That means bc2 will be equal to 2bm. That means whatever the voltage it is dropped over here, 2 times the voltage will be dropped in this capacitor. bc2 will be equal to 2bm. So again in next polarity what we will see, that this one will be positive, this one will be negative. Then these two capacitor these two diode will be forward biased, these two will be reverse biased. So now we'll see in this compartment. In this compartment this capacitor is charged. Okay, so it is a closed circuit. So what happens now, then the negative charge from this capacitor flows to this one, positive charge from this capacitor gets flow to this one. Okay, so at this case we can say that this capacitor is negatively charged, this one is positively charged. So again if we apply Kirchhoff's voltage law over here, then again we'll see the value of bc3 will be equal to this one, because we are applying Kirchhoff's voltage law. 2bm minus bc3 is equal to 0. Again bc3 will be equal to 2bm. Okay, and again after this, okay, after this we will see the next polarity again. If here is positive and if here is negative, that means this one will be forward biased. Okay, this one will be forward biased, this one will be forward biased, these two will be reverse biased. That means if it is forward biased, it acts like a closed circuit. Okay, and this one is reverse biased, it acts like a open circuit. There is a break. Okay, imagine there is a break. So in this compartment, if we see that there is a positive side of this capacitor, then this one will be charged by the positive one and there is the negative, so this will be charged by the negative one. So in this compartment, if you again apply Kirchhoff's voltage law, let us consider this one is bc4. That means what we can write here as, in this part, in this compartment, okay, bc4 minus 2bm will be equal to 0. That means bc4 will be equal to 2bm. So we know that here is a 2bm voltage, that means twice of the given voltage. Okay, whether we are supplying 6 volt or 12 volt, it is upon our choice. Here is 2bm, 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 and here is bm. So we can see that in the same compartment this bm voltage is dropped here, 2 times of its voltage is dropped on the 3 different capacitor. So after this, whenever we measure a voltage from here to here, we are going to get a value of bm, that means 6 volt or 12 volt. So whenever we are going to measure from here to here, then what type of voltage we are going to get in this compartment? These two capacitors are connected in series, so we are going to get bm plus 2bm is equal to 3bm if we are going to measure from here to here or either from here to here. Okay, because there are two capacitors in a series. Again if we are going to measure from here to here, then two capacitor is measured in series, so we are going to get a 4bm. So it is a simple logic for a voltage multiplier. Okay, whenever you design this circuit, don't forget to measure the voltage in this capacitor leg here, here, and here. Okay, and whenever you measure from here to here, you will get a 3 time. Whenever you measure from here to here, you are going to get a 4 time. Okay, this is the simple logic of voltage multiplier. Okay, now one thing I need to say, that if here is it AC voltage is dropped here. So in the several different capacitor, there are going to be dropped a DC voltage. Okay, don't forget to measure here a DC voltage because the charge is stored over here. So then it is all due to this diode and all. So here will be the DC voltage. So one thing I want to say that, do you remember this point? So from this point you need to join this circuit. Okay, this circuit, 100 ohm capacitor is connected, resistance is connected here, 100 microfarad capacitor is connected to the ground, and 10 kilo ohm resistor is connected to the ground. Now why we need this type of circuit? It is so because here we are going to convert all AC into DC, but at this point, it is the last point. Okay, at this point we want to check that what type of AC signal is still present here or not. Okay, if there is any kind of AC signal present here or not. So for this we'll design this circuit, and from here we'll join a oscilloscope, and one probe of oscilloscope will be connected to here, one thread of that probe, and another will be connected to ground. So whenever we see in the oscilloscope, we can see the rippled output. Okay, in this case it will not be like a sinusoidal wave. Okay, but it will be like a ripple. Okay, it will be like a ripple in this type. Okay, it will not be like a sinusoidal wave, but it will be in the form of ripple. And don't forget to measure the voltage of ripple. This many volt of ripple is present over here. You need to say like that, and you need to conclude your um, experiment. Okay, and while measuring this ripple, take in case of two probe of oscilloscope, one probe you connect over here. That means we can see the input voltage, and after that input voltage will be in the sine wave, and another keep it on up, and at last you connect the other probe over here, and you can see this type of wave. Okay, I hope you are clear about this term of voltage multiplier, how the voltage is going to multiply. This circuit is not only stops over here. You can connect several other, and you can multiply the voltage to the different term whatever you can choose. Okay, okay, thank you very much for today. You all are very much, I am very much thankful to you all, to you, because you are watching this video. Okay, thank you very much.